Hi everybody, my name is Alessio Trevisan and I am the SDC Verifier product manager here at Engine-Soft. I work on offshore and construction department since 2007, where I used to calculate special structures for that field of activity. So I'm very happy today to introduce you the business development manager at SDC Verifier, Bodan Solonko, who will show you the powerful features of SDC Verifier and its seamless integration with Ansys, a leading FEA platform. So I give the floor to Bodan without further hesitation.
Thank you, Alessio. Hello, everybody. It's a pleasure to be here. As Alessio mentioned, my name is Bohdan. I'm Business Development Manager at SDC Verifier, working closely as well with our Italian renowned partners, Engine-Soft. Today, we will talk about something that sometimes I even found unrealistic when I hear about it, is by cutting something by half or 50%, but we will show you and prove how you can save a lot of time doing structural verification according to standards in Ansys with our software. I will start sharing the screen. Okay, 1 second. Okay, can you confirm if you can see my screen already?
Yes.
Good, perfect. So, yeah, let's begin. So today we will talk about cutting code check time by 50% and how to automate your structural verification workflow in Ansys for Ansys users with SDC Verifier. Okay, so let's begin with, for those who never heard of us or who have a little understanding about what SDC Verifier is as a company, I'd like to dedicate a few slides to let you know more about SDC Verifier as a company. So, yeah, the company itself was founded a long time ago in 1998 in the Netherlands, and by our founder, professor of mechanical engineering in one of the universities in the Netherlands, in Delft University, Walter van den Bos. If you're visiting industry events around Europe, you could have bumped into him. So the core activity of our business was consultancy services, but repetitive and time-consuming routine have motivated us to also create FEA-compatible products for structural verification in 2009. We start with integration of our products with FEMAP, and later on proceeded with integration of our products with Ansys. Currently, SDC Verifier team has 33 people. Our team consists of experienced engineers, so we not only create the software because we want to, and this is something that market dictates, but we have a team of engineers who take active part in the development of the software because, as you might have already understood, they are using it for consultancy services on a daily basis. SDC Verifier is Ansys Advanced Solution Partners. SDC Verifier is Siemens partner, active member of PIMA, NAFEMS, and as well as IRA. So we currently have 3 offices. Our headquarters is based in the Netherlands, and we have 2 offices in Poland and in Ukraine. And of course, a great volume of our business is done through partners and with partners. And yeah, we are proud to have reliable partners around the world. And special thanks goes to Engine-Soft team in Italy, who we do a lot of business with. And again, thanks for organizing this event. So let's talk about what could be the main struggles when it comes to code checking for engineer who, apart from code checking task, has a lot of a lot of duties, a lot of procedures to follow, a lot of simulation, design, other tasks. So let's say the first one, in my opinion, is repetitive and time-consuming calculation. So if you have a really like lots of load cases you have to follow, and if you are not using any kind of software, you're doing it in spreadsheets, it can take really a lot of time for yourself. The code checking process is also error prone because, again, if some kind of spreadsheets hand calculation is your option that you're doing structural verification with, the error margin is really big, and it's normal because we are all people, and we'll still make mistakes with code checking and spreadsheets until robots arrive. But let's be honest, they will do a lot of mistakes in Excel as well. And of course, if you are working with the software and you are doing your model in Ansys, but you're doing code checking in some outside software that does not have any kind of connection with Ansys, you can also lose a lot of time by doing back and forth with modeling. So you have to do the part of job in Ansys, then you have to export your model to this external software to do the code checking, then you have to import this model to Ansys again. So it's really time consuming, in my opinion. Then, of course, working in various industries with different projects, you may have too many standards to follow, and of course you don't have a library when they are all properly stored and managed. Also, the huge challenge is identification of the structural members, because in Ansys we are building FEA model that's built consists of thousands or millions of finite elements, and basically the code checking is done on the structural members, so it's also important to be able to identify those members. And also, of course, last but not least, is the reporting to your customers, reporting to your line manager, reporting to certification societies such as DNV, BV, ABS, Lloyd's, and more. So yeah, you need to have all this tedious work that you have done. You need to properly report it in a proper manner, in a proper format, and get your structures certified. So basically, all of this can lead to a big headache, deadline pressure, and why not find a way how to overcome these obstacles and basically live a happy engineering life. So of course, we are, as a software provider, happy to provide this solution to make the code checking process great again. Currently, as a company, we have four main different products, that is SDC for Ansys, SDC for FEMAP, and SDC for Centris 3D. This option works as a powerful add-on to FEA programs to basically conduct checks according to rules and regulation inside the software without the need of any external applications. The software also conducts all pre and post-processing action, design optimization, extensive reporting, and also we do have a very exciting project, a very exciting product that we have released last year is SDC Verifier standalone version with built-in Nastran solver, which also gives you a possibility to do some modeling, simulation, calculation, code checking, and also import and export tools. So this is the product for someone that, for example, doesn't have Ansys. But of course, today we are gonna concentrate on one product. This is SDC for Ansys. In this diagram, and if you ever encountered with SDC Verifier products, and if you'll do it in the future, you'll see this circle a lot. Here, a typical SDC Verifier workflow is presented. So first and foremost, we are starting with modeling in Ansys, and the SDC Verifier seamlessly connects to Ansys, reads your FEA model, and allows using loads and load combination and applying it to the model. In SDC Verifier, at the second step, you can apply multiple load combination. So as you can have understood it already, SDC is not only a post-processing tool, but a pre-processing tool as well. After this step and before performing any kind of checks according to standards, whether it's a plate buckling, fatigue, or anything else, you need your structural items getting recognized, actually. So as I already mentioned before, in Ansys, you only have finite elements in your model, so we must let the software know where the beams are, where the plates are, and where the bolts are, depending on what kind of checks you are about to perform. With our recognition tool, this process is done with one click. I will show you later. And basically, this is the main step that enables the code checking process, which is actually the next step on our diagram as well. Yeah, in our library, we have more than 40 predefined industry standards, and we also provide you with, because it's not possible taking into account how many industries we work in. It's not possible to implement all the code checks that engineer might need. So we also provide you with interface to implement your own code checking routine, implement your own codes, have it password protected for your use, and basically use it. After the code checking procedure is done, it's possible to generate extensive report that includes not only the results of code checking, but also data inputs from Ansys, so results of FEA analysis and results of code checking could be combined and exported to Word or PDF or PowerPoint, and as I mentioned, be presented to manager, customer, certification society, and so on. We also have optimization tool that allows you to make best design decision for your structure by basically calculating different combination of design input. As you already figured out, the arrows that you can see around the circle mean that if you have any changes to your design, the process could be repeated automatically with enormous, and I will repeat it again, time-saving benefits. So you might ask how the software actually works with Ansys. It's connected through the ACT to provide the connection between SDC and mechanical, and it could appear in your Ansys as a ribbon, so in basically embedded mode. And as Ansys advanced solution partners, we have a chance to enhance the workflow of hundreds of Ansys using companies around the world. So SDC Verifier, if you, for example, use two screens, SDC Verifier could be used on in a standalone mode, so you can have your mechanical on one screen and SDC Verifier on another screen. We already talked about embed mode, so I will just click through it. So now it's time to briefly discuss the main steps of our workflow. We already pointed out that all you need to do checks, let's say according to Eurocode, is apply your loads, recognize structural items, perform checks, generate a report, and make sure that all requirements, excuse me, all requirements are met. So let's discuss our load. This is a typical example of the standards here on my screen. You basically use different partial safety factors, dynamic factors, and at some point you need to come up with a kind of matrix. You have your weight, discharging loads, some influence, specific loads like wind influence, and then by using various factors, you end up with different load combinations. The big perk of a software is that you have, if you have a spreadsheet, for example, that you are using in Ansys, you can simply copy and paste them from the clipboard directly to SDC Verifier, and you get the same table as you can see in the right bottom corner. Without SDC Verifier, you are solving basically one load case as one step in Ansys, and it's not very handy and not very economically in terms of time. The SDC Verifier logic is a bit different. We say that each load is going to be considered as a separate step. So you have your own weight of structure here, discharging loads. Each load will be considered as a separate step in Ansys, and we call it an individual load. This also means you need to analyze these steps just once, and you don't have to reanalyze them again and again if you have any changes to your design. The rest you can do in load set, which is the linear combination of various loads. If you want to find out all the results simultaneously in one picture, you just add them to a load group, and it will show you the worst result within one picture or, for example, one table. In the end, this is how your load cases according to standard look like, and you easily transfer them to SDC within one click. SDC also has several important built-in tools. The governing load tool helps you to identify most important load combinations only. So you can see at this slide that we had 132 load cases, and after using the governing load tool, we figured out that only 8 of them are causing the maximum stress level. So you can see that for any improvements, you need to calculate only this specific color-coded load set that were defined by the software. If you check, if you check your stress, sometimes the maximum stresses appear inside of the structures, and of course, for us it takes a lot of time to check them visually. So here we also offer as a complementary tool a peak finder tool that do that job for you, basically eliminating any possibility of mistakes and being your second pair of eyes. When we are talking about the Eurocode again, we want to know if your utilization factor is below or equal to 1 as predefined by the standard. So you say to the software that you want to have all utilization factors above 1, and it will find problematic areas within a second. So yeah, you can see left bottom corner that it's identified all the values starting from 1.25 to 3.37, and so you can see those areas and improve them if needed. You can also have these diagrams presented. So shear force that refers to the force that acts parallel to the cross section, and bending moment occurs when external force is applied. So these diagrams are also available as pre-processing tools in SDC Verifier. Specific loading, of course, is a really important one. So we have a wind load, buoyancy load, and wave load that could be applied to your structures. So in case, for example, if you're talking about a wind load, the idea is you simply set up pressure or wind velocity, check direction of how this force applied, and then it applies to your model automatically. As I mentioned before, to run the checks, we need to actually recognize the structural items. For example, if you want to run a joint check, connection check, or buckling check, you need to have all these items recognized, which in your Ansys model are just millions of finite elements. So if you have part of models with beam element, the software automatically finds all these beam members within your model prepared in Ansys. The same applies to join, and you can see they are also recognized with proper dimensions. This is basically how it works. You see your Ansys model and a short video of how easily these are getting recognized just with clicking find button. You see that 119 joints were recognized and automatically, and The number of joins that you have in the model doesn't matter, because we can identify as many as possible, and as many as you have in your model. And this is how the FEA model looks like after the structure members are recognized. The same, basically, you can see recognition of BIM members, absolutely the same logic. And the same logic, of course, applies to finding BIM members. Again, you just click find. It takes, of course, for a bigger models, it will take much more time than it took here for 90 members. But again, this is a really automated procedure that will save you a lot of time, and yeah, save you from a lot of headache with recognition of structural items. And this is how it will look like after it's done. The same applies to recognition of beam sections, and also it's important to know that our software is mesh independent. If you are working with any kind, if you're working in shipbuildings, of course, you'll have to also identify and recognize this global structural elements such as decks and frames and longitudinals. Recognition of plates works exactly in the same way. I'm just showing you the rich capabilities and how many items we can actually recognize. And again, it's mesh independent. For the panel finder, we also have an example of short video, how you can identify your panels, and also it works within a few clicks. You can identify panels, plates, and stiffeners for plate buckling, for all plate buckling standards that we have in our library. And this is how it will look like after recognition is completed. Same works for stiffener recognition. You can see the stiffeners within this panel that are identified, recognized, and ready for code checking. If you want to perform a fatigue or weld strength check, you need to have welds recognized. On the top left of this slide, you can see the welds are simply highlighted in the model. On the right, you can see what the recognized welds look like. But we not only do the recognition of welds, but also the recognition of welds intersection. As you know, they are the weakest points if in terms of fatigue. Stresses are also automatically reoriented in the weld direction, which is not easy or impossible to do, for example, with hand calculation. And this is, again, how the actual process of weld recognition looks. You have the model here from Ansys with the welds. And again, just click find. Quick and easy process. Welder recognize. You can see what parts are welded and non-welded. And you can see the list of all welds within your model. As you can see, we have easily identified hundreds of welds, and here we can also apply weld type, double full penetration, double fillet, partial penetration welds, and so on. And here, how it will look like. But also, it's important to note that if you have any exceptions in your model, you can set them up and mark as exception, and it won't be considered in fatigue calculations. With the latest release of SDC Verifier, we are now also able to identify and recognize 3D elements. So we are ready now to recognize also welds in solid models. Again, now one of the biggest benefits of the software and what recognition brings to it is that you can keep all your processes of structural verification according to standards within the same model, and you don't have to go back and forth a few times between Ansys and other tools that are not connected with mechanical the same way as SDC is. Now it's time to talk about the standards. As I already mentioned, we have more than 40 standards in our library. You can see them on this diagram, but here is actually the list. I'm not sure because we are not updating it as often as we have new standards released. So yeah, you can see that we have such standards as ISKI, ABS for playback link, API, some Australian standards, 2ASME standards, DIN standards, various DIN-V standards. Also, we have added Bureau Veritas for playback link lately. We have a lot of Eurocode standards for members, weld strength, fatigue, playback link, connections, fire design, bolt checks. We have FKM 6th edition and 7 is now in the stage of development. We have ISO 19902, NORSOC, and FDI 4DI 2234 for bolt checks as well. I'd also, while we're here, I also like to share our implementation plans for what we are about to implement in the next release. Our releases are usually happening within the space of 1 or 2 months after new version of Ansys is released. So we take this opportunity to make them compatible, to programs compatible, and also add new features and new standards. So in the next release, we will have ASME BTH1, which is the standard that provides minimal structural, mechanical, and electrical criteria for behind the hook devices. And we will also update the joint checks for ISO. We will add single fillet asymmetric welds for weld strength, and we will implement T sections and L section for ISK rules. As I mentioned, FKM7 is going to be implemented, and we will also add a torsion check for EN 199311 members. And also we are planning to add FEM stability checks for beam buckling and hull buckling. So it's also important to mention that our checks are open. SDC is not a black box, and we do not say to you, listen, we are the expert here, so trust us. Your structure is okay or not okay. Now that's not how we work, and this is also a huge benefit that it's always mentioned by our customer, that they have the understanding of what the results they are getting and where they are getting them from. So yeah, here you can see all the formulas. You can edit the formulas. You can add your standards if needed. You can see full calculation procedure, intermediate results, and so on. Here you can see a result and an interface of how to add the code checks. So if you'd like at some point to use SDC Verifier and we don't have a standard that you have to work with, you can add it yourself following simple Python logic, using variables as inputs for the standards. We have tutorials for that, so that's really, really easy and convenient to do. Let's now proceed to presentation of the results. Typically, results in SDC Verifier are presented in 2 ways or 2 styles. The first one is the plots, as you can see, and also the second one is the table that you can also work with. For example, when you do fatigue check according to Eurocode, you have different classifications. So depending on the direction of your load and also type of your weld, you are ending up with different characteristic strengths. After that, the boundary minor rule is used to end up with the stress history for fatigue. Based on our practice, this is very accurate method. In this case, there were no problems. No problems were found with the structure until FEA analyzes detected this huge crack over 30 centimeter that you can see on the photo. The same could also be done for Wellstone check. It's very time-consuming process if done by hand or in a software that is not connected to Ansys like SDC. With SDC, you can recognize all the welds and set up size, weld type. So basically, all weld dimensions would be considered, and you can also edit some parameters here and change the length. For example, if you need to change the length of your weld. Forces and the moment over the weld and compare it to resistant to get the result to see which weld are okay and which aren't. On this slide, you can also see the implementation of custom bolt and rivet check as example. And as I mentioned before, we not only give you an answer if the structure is okay or the structure is not okay, but we give you the precise result of each bolt and show you which one needs to be replaced. So as you see on the picture in right bottom corner, we can see the bolts, and 2 bolts marked in red should be basically replaced. And what is very important for certification society, it's important for third-party verification. If you have companies that also verify that the customer want to verify your design, it's really important that we are storing full calculation history and we present it to you, to your customers, certification society, managers, third-party verification, whatsoever. So all the things in full procedure stored and could be reported. You can see that we can see here the chapter, the formulas, the value, basically full story when it came from. So you'll ask, okay, we did the code checking, what's next? And the next, typically, if everything is fine, you have to generate a report. Our reporting tool allows automatic generation and export to popular formats such as Word, PowerPoint, or PDF. Advantage here is that you just build your structure here as shown on the left, and it's automatically sorted on the left with different sections. So you have easy navigation across your report if the report consists of hundreds or thousands of pages. And this is the interface of the report designer. The report designer, based on drag and drop option, you just build here what you want to see, and you can save it as a template and use it for all your projects. You don't have to set up report procedure from scratch every single time. So as well here, the procedure with reporting is again could be 100% repeated. Then we should, let's guide through some options that are available in enterprise level of SDC Verifier. So sometimes when we say that the structure is not okay, we don't leave you with that information. We will provide you with optimization tool that allows you to make the best design decision for the structure by calculating different combination of design input. When we are looking at situation, you can simply come up with a list of options from our library you'd want to check. So you can check different type of beams. The software will determine the most optimal solution for your specific case, and you can automatically replace it in a model as well. The same could be done for plate and stiffener optimization. You can have different plate thicknesses and set orders of panels, optimize it, and thickness of different stiffness type. And same, of course, works for weld optimization. This is basically how interface of optimization tool looks like. So you can see that we have original shape of beams, and we have the library of beams you can replace them with. Also, the really important tool that we have as a hotspot stress is a more advanced fatigue method, as you know. So it evaluates structural integrity of welded joints, and it focuses on areas with high stress concentrations, which are called the hotspots. The hotspots. This approach provides us with a more accurate assessment of fatigue performance compared to the nominal stress method. And in SDC Verifier, the hotspot stress method is implemented by interpolating stresses at specified reference points near the welds, and the software automates this process, allowing efficient and precise fatigue checks according to various standards such as Eurocode 3 fatigue and weld strands, DVS, DNV, DIN, FKM, FEM, and EN 13001. Also, Rayflow counting tool we have in our library, and this tool is used for analyzing fatigue in material that are subjected to varying stresses. So this method simplifies complex stress patterns into cycles, which helps predict material failure. The process involves filtering peaks and valleys in stress data, removing minor stress variations, and categorizing stress cycles. The tool, of course, is integrated into SDC Verifier software, and we find it as essential tool for engineers who are following fatigue standards in industries like heavy lifting and offshore, as it basically enhances accuracy and also efficiency of fatigue analysis. Also, we offer our customers extra automation with open API. So it's basically a well-known set of methods that help automate the process of your interaction with SDC Verifier. So if you have this programming spirit in you, you can elevate it and leverage it to your best, and script and program SDC Verifier how you like it to work. So let's sum up what SDC Verifier actually is. SDC Verifier is code checking in FEA programs, and also, as I mentioned, as independent entry-level interface. Majority of popular standards, especially within Europe, are available. Standards can be customized to your specific needs. Total calculation procedure is saved, and we offer extensive reporting that is crucial for customers and certification society, and also design optimization. And basically, we provide you with a platform to, I find engineering not only precise as a really precise field, but also field of creativity. So yeah, we provide you with a platform with various tools, and it's a matter of engineering judgment sometimes how to use it to your greater benefit. So based on internal research that we made and some statistic from our customers, we can see how efficient the implementation of workflow of SDC Verifier can be over different steps, starting from hand calculation. You can see the time difference is huge, proceeding with working with standards and reporting. Of course, reporting saves you hours, and depending on the project can save you days with generating the report of FEA analysis and code checking as well. So when you pull all these things together, it's evident that SDC Verifier could save as much as 50% of your valuable engineering time. This is something that I mentioned at the beginning of the presentation. This is, again, as I told, these numbers is something that is not easily believable, but I'm pretty sure that you have seen these benefits and potential of time saving yourself. I'd also like to mention the industries that we work in. So we are really strong in the field of oil and gas, offshore and maritime, heavy lifting, machinery equipment, shipbuildings, pipes and petrochemical, aerospace, renewable energy, obviously civil engineering, engineering services, and some other industries like mining, or we have also as our clients steel production, some telecommunications companies, and so on. So around the world, directly or with the help of our partners, we do have now more than 150 enterprise customers around the globe. You can see some well-known names here, starting from Technip FMC, Subsea 7, Petrobras SBM Offshore, Siemens Energy, some Australian companies for telecommunications, ADNOC, and so on. It's also important to mention that, as you can see on the left side of the slide, that Bureau Veritas exploitation is our user. So, and it's also critically important to us to maintain communication with certification societies, and that's what we are doing now. So we are communicating with ABS. We were in their office last year. We had a lot of meetings with Lloyd's, with DNV, and with Bureau Veritas to actually simplify the process of submitting the reports of the customers of SDC Verifier to this society, and save you even more time and provide even greater value to you as a user or as a potential user. Of course, we have several feedbacks about how SDC Verifier works, what it can save, and you can see that all SIS used SDC Verifier for code checking of their pioneering Spirit vessel, and yeah, 4,000 pages of results, and were transformed into report, created in 2 days, and by their observation, it saved them weeks, if not months. And again, SDC saves a lot of time on backlinking analysis, and reduce the check error probability compared to a hand check with spreadsheets, and so on. For all the users, for all the people who would like to test the software, you can reach out to EngineSoft, to Alessio, or the other team members to ask for SDC Verified trial license. On top of that, you can go to our website, you can download the software, and you can request the software yourself and give it a go. We do have a really great testing logic, I would say, and we have prepared on our website a lot of step-by-step tutorials. So these tutorials are prepared by our engineers, and yeah, you can basically see the tutorials on how to get started with SDC Verifier, report designer. There are also dedicated tutorials about different checks, different group of checks. So I would say that SDC Verifier is not only really valuable software that could be used in various industries and save you a lot of time during the actual job, but it's also the software with pretty easy onboarding, with great support from both EngineSoft and SDC Verifier team. And this is something that you could speed up to, streamline, and basically master in matters of weeks. So with that, I would like to thank you for joining us. I'd like to thank EngineSoft for organizing this event. If you'd like, please give us a follow on YouTube, on LinkedIn, and we post a lot of handy content on YouTube. There is a lot of updates and engineering materials on our LinkedIn. So yeah, give us a follow, and let's stay in touch. And thank you for attending this webinar.